All right, here we go. This is the last lesson in Unit 5 as we continue to look at solving systems of equations and inequalities. Today we'll focus on those inequalities. And it's kind of an action-packed lesson because we're going to be looking at doing two different things. First of all, learning how to graph a linear inequality, and then combining that into solving a system of inequalities. So it's stuff that we've done before. We've solved linear inequalities before, and we've graph systems of equations. We'll kind of combine all those together today. So, as we get started here, let's just take a look at what we know already. First of all, how many answers are there to this equation? X plus 3 equals 2. Well, we know that there is only one solution. That's when x equals 2. Okay? So, oftentimes there is exactly one solution. Then we got into absolute value. How many solutions are there? Well, x can be equal to either 5 or x can equal negative 5. So there are times that we found that there are two solutions to an equation. In this case, the absolute value of negative 5, well, there's no solution here. So some equations don't have a solution because I can't take the absolute value and make it a negative number. Okay? Because there's never a negative distance from 0. Then we got into absolute value inequalities. When is the absolute value greater than 5? Well, we said that value, we made our number line. What numbers are more than 5 away from 0? Well, we said, well, it could be anything greater than 5 or anything less than negative 5. So we said it's either greater than 5 or numbers that are less than negative 5. And we represented that on our number line to show that all those infinite number of possibilities. Next, we talked about an equation y equals x plus 3. Well, I could say, well, if x is 0, my y value would be 3. But if x were 1, it would change. My y value would be 4. If x were 2, my y value would be 5, and so on. And so we represent that by just plotting all those points on a graph, and then we'll find that we have an infinite number of points, and we just change that into a solid line to represent the infinite number of solutions. So next we talk about inequalities. And if we test these points, why don't you just go ahead and check to see which of these is a solution to the inequality. Start the video again when you're ready to check. Okay, so we found two of those were not solutions. Negative 3, 0, because when I plug 0 in for y, and negative 3 in for x, is not a solution because 0, it says, should be less than negative 6 minus 4, which is negative 10. And 0 is not less than negative 10. So that makes it not a solution. Whereas when we put negative 2 in for y and 4 in for x, find that is true, a true statement. Because negative 2 is less than 4. Okay? So we have three solutions, two that are not solutions. So when we put those on the graph, along with multiple other solutions, the solutions in green dots here, and the non-solutions in X's, you start to see a pattern. The solutions start to fall on one side, and the non-solutions are on another. And if we're looking at our equation, y is less than 2x minus 4, hopefully you can pick out where that line starts to reside. I see kind of a point right along here. And the dividing line kind of goes along like this. Do you see any connection with that dividing line? What is this point? This is at 0, negative 4. And it looks like this line is sloping up 2 over 1. So we can see where we get our dividing line. There's that connection right there with the form of that inequality in slope-intercept form. So we'll talk about that and talk about how we shade that whole line because we know everything on this side is going to be a solution. Just like in a number line, we drew our arrows representing which way on the number line were solutions. And then there's a difference here between when we have a line when it's not equal to. We have a dashed line. I'll talk about that as we go along. First of all, let's just get some terminology down as we begin here. Linear inequality in two variables, that's something like this. 2x plus 3y is greater to 5. We have two variables, x and y, and we've got an inequality here. A solution is any ordered pair like our x, y, that makes the inequality a true statement. Okay. So as we take a look at our graph here, if I want to find out the solutions, we need to find anything that's going to make this true. And we could make a table and just start picking numbers and finding which ones are solutions and which ones aren't. But there's an easier way to do this. So we get our, let's get the y by itself. And let's divide by 3. Y is greater or equal to 5/3 minus 2/3 x. So I know I've got a dividing line. My intercept is 5/3, 1 and 2/3. I've got a slope of negative 2/3, so down 2/3. And now I've got to figure out where my solutions will lie. Well, let's just try a point. Let's just try 0, 0. Is 0, 0 a solution? If I put 0 into my equation, 2 times 0 plus 3 times 0, it needs to be greater or equal to 5. Well, 0 plus 0 is 0. And is 0 greater or equal to 5? No. So this is not a solution, so we can put an x here. So that's not a solution. And so as we saw before, anything on this side of the line will not be a solution. So I know anything on the other side will be a solution. So I can shade those in. Those will be all the solutions to the inequality. So let's go through a couple more examples as we take a look at that. Okay, so let's go step by step here. The graph of linear inequality in two variables, that's just a set of all points that represent all the solutions. So the first thing we want to do is graph the linear inequality. Y is greater than negative x minus 4. So first thing to keep in mind is if it's in slope-intercept form, we just graph it and we just pretend it's like y equals negative x minus 4. Okay, we're going to graph a line for that because that's where the boundary line is. Because we know the set of all solutions is on a half plane, we call it. And so it's divided by a line. So key thing to keep about the line is that the line, just like we did with a number line, when x was less than 2, on a number line, we represented that with an open circle because it didn't also include 2. Or when we said x was less than or equal to 2 on our graphing, that's where we said at 2, we want to put a closed circle because it also includes 2 and everything less. Okay, so same process applies. When we talk about graphing the linear inequality, we're going to use a dashed line for less than or greater than because it doesn't include anything on that line, and a solid line for less than or equal to, greater or equal to, because it also includes those. Okay, so first thing we want to do is graph that line. So our intercept is at negative 4, and our slope is negative 1. We're just going to graph that down. And since it's greater than, I'm just going to put a dashed line to show where my boundary is. Okay. Next, we choose a test point. Make sure it's not on the boundary line so we can see which side of the equation is. So if you can, choose 0, 0 because that's an easy one to test. So if I choose 0, 0 as my test point, I'm going to plug it back into the inequality. So my inequality is y is greater than negative x minus 4. I'll plug 0 in for y and 0 for x. So 0 greater than negative 0, which is just 0 minus 4. Is 0 greater than negative 4? That is true. 0 is greater than -4. So 0, 0 is a solution. Since it is a solution, we're going to shade the half plane. I mentioned that before. That's everything on that side of the line that contains the solution. So since I know that 0, 0 is a solution, I know that everything on this side of the line will be a solution with it. So I can shade all those values as well. Okay? The question comes in, well, what if I would have chosen a different point? Let's say I would have chosen this point right here. -1, 2, 3, 4, 5, 6, -7, 0. Well, if I would plug that into my inequality, plug in 0 for y, and -7 for opposite of x, that would make that +7 minus 4. Is 0 greater than 3? That is a false statement, so this would be false. So would everything else on this side of the inequality, which would mean the opposite side would contain all the solutions. So that's what to do if you come across something that is false. Now let's talk about systems of linear inequalities. So the system, we're looking for solutions that are in both inequalities, just like we did when we graphed equations. We graphed both lines, found where they cross. Here we're going to graph both inequalities and find out where their shadings overlap, and that overlapping area is the solution set. So first thing we'll do is we'll graph these two inequalities. This one's in standard form, so I could find the intercepts for that. Remember, we do that, we can cover up the y and say there's 0 for y, so solve 2x equals 6. Therefore, x is 3. So my x-intercept is 3. Cover up the x, put 0 in for x, and solve for y. 3y equals 6. Therefore, my y would be 2. That would be 0, 2 as my y-intercept. Since it's greater or equal to, we would put a solid line in there. Okay. Keep in mind, if you want to switch that over to slope-intercept, you can do that as well. Subtract 2x from both sides, and I'd have 3y greater or equal to 6 minus 2x. Divide by 3. Y is greater or equal to 2 minus 2/3 x. Intercept of 2, slope of down 2 over 3. Okay, notice we get the same line. Now we choose a test point. I would choose 0, 0 because that's easy to work with, easy numbers to multiply. Plug it back in. So 2 times 0 plus 3 times 0. That should be greater or equal to 6. Move that down here. So 2 times 0 is 0, 3 times 0 is 0. So I have 0 plus 0 is 0. Greater or equal to 6. Is 0 greater or equal to 6? No, it's not a solution. So now, since I have two inequalities, I'm just going to draw an arrow now showing where this side will be shaded. Okay. If I want, I can shade that whole thing. Find out why later. I like to draw arrows myself, but I'm just shade it all in for now. Next, let's take a look at the other line. I'm going to graph that one in black here, so it's a little bit different. So I have an intercept of 0, slope of 2/3, so I go up 2 over 3. This one is just less than, so it's going to be a dashed line. Now I can't choose 0, 0 because it's on the line. So this time I'm going to choose 1, 0. So if I put 1 in for x and 0 for y, do that down here. So 0 less than 2/3 times 1 is 2/3. Is 0 less than 2/3? Yes, it is. So that is a solution, so is everything on that side of the line. So I could draw arrows to show me which way I'm going. And I'm going to shade everything over on that side. Now, where is the overlap? Where is the black shading overlapping with the blue shading? Hopefully you can see that. And this is going to be our solution, what I have shown here in red. I know it's kind of a mess right now with all this shading. And that's why sometimes if you draw arrows to show where it's going to overlap, it might be a little bit simpler. So I know that everything now in this red area where I'm putting x's would be a solution. If I wanted to find a solution, I could pick any point in there. That represents all of our solutions. Okay. So why don't you try this next example and try to shade that, and you can check to see what you get for that one. Okay, so hopefully I have the chance to graph that. Notice I rearranged this first equation. I did that one in green. Got the y by itself, so you can see my work there, and an intercept of -3, slope of 3/5. It's also equal, so it's a solid line. I put my test point of 0, 0 in there. Found out that it was false, so my solutions will be on the other side of the line. Next equation I did in inequality, I did in blue. Got y by itself, intercept of -4, slope of -2. Dash line, because it's a less than symbol, no, not also equal to. I put a test point of 0, 0 also. Found 0 less than 4, it's a true statement, so those were solutions. So notice when I draw the arrows, I can see where those overlap. And I can see that it's going to be in this bottom quadrant here. Will be all the solutions. So like I mentioned before, sometimes drawing arrows makes it a little bit neater, easier to find, or maybe you prefer to shade both and see where they overlap. Just do what is comfortable for you. All right, so let's finish up here by taking a look at how we graph 3 inequalities and how we write a system of inequalities for those. So why don't you just start off by trying to do that first example, the 3 inequalities. Restart the video when you want to see how it looks. So notice in green I did x greater or equal to -3. That's a vertical line through the x-axis at -3. Numbers that are greater, I can check 0. Is 0 greater than or equal to -3? Yes. I'm going to go to the right of the line. Y less or equal to -2 goes to the y-axis at -2. I can choose 0 as a test point. Is 0 greater than -2? No. So we're going opposite there. And this one I graphed in blue, I found the intercepts. So 3x is 24, therefore x is 8. 6y is 24 when I plug an x in for 0. So I get the y-intercept of 4. 0, 4 as a coordinate. Complete that. All these are solid lines because they're also equal. Choose my test point of 0, 0. So 3 times 0 plus 6 times 0 is 0. Is that less or equal to 24? Yes. So notice I can see where all these arrows are pointing. Where do they all overlap? In this region here, except I think I made a mistake, didn't I? Y greater or equal to -2 here. That should be going the other way, shouldn't it? Because 0 is greater than -2. You're probably shouting at me right now, trying to tell me that I made a mistake, but I can't hear you. Remember that? You're watching a video. So anyway, where they all overlap would be this section right here. Okay, so that's where all the solutions would lie. I could say, well, 0, 0 is a solution. 1, 0, 2, 0, 3, 0, 3, 1. -2, -2 would be a solution. So anything in that region. So finally, let's finish up with writing. We're given the inequalities. Let's write them all out. So here's our system. So let's take the lines as we have them. This one, dashed, goes through the y-axis at -2. It's a dashed line, so it's just less or greater, and the shading is above that, so it's going to be greater than -2. The next line that we see is this one, and that is in slope-intercept y equals mx plus b. So our intercept is -1. Our slope, up 1 over 1, so 1x. It's also equal because it's a solid line, and it's, let's see, are we above or below? Everything is less than that. So we'll say it's less or equal to 1x minus 1 in order to make that true. And that looks like all of our boundaries. So that would be our system of inequalities related to the graph that we have up there. So we did quite a bit today. We looked at systems of inequalities. First of all, started off with how to graph one single linear inequality, and then showed how we related that to systems. So do some practice work with that. If you have questions, let me know in class.